You are sitting comfortably at 35,000 feet. The flight attendants are serving drinks. The pilots sound relaxed. Then the plane suddenly drops. Your stomach stays somewhere near the ceiling. The coffee launches itself toward the passenger behind you, and your brain immediately begins preparing a farewell message. The strange thing is that the aircraft may have moved far less than it felt. Turbulence can feel violent, unpredictable, and deeply personal. But most of the time, the airplane is not falling out of the sky. It is simply flying through air that is moving. So why does turbulence feel so dangerous? What is the plane actually doing? And should you be worried when the wings begin bouncing outside your window? When you look outside an airplane window, the sky appears calm. There are no roads, no potholes, no speed bumps, just empty blue space. Unfortunately, the air did not receive that information. The atmosphere is constantly moving. Warm air rises, cool air sinks, winds change speed and direction, mountains disturb the flow, storms push enormous columns of air upward and downward. High above us, powerful jet streams race around the planet. Air may be invisible, but it behaves more like a moving ocean than an empty room. Imagine a small boat crossing water. When the water is smooth, the boat moves gently. When different currents meet, the boat begins to rise, fall, and roll. An airplane experience is something similar. The difference is that the ocean surrounding the aircraft is made of air, and you cannot see the wave that is about to hit you. That is why a completely clear sky can still produce turbulence. No dark clouds, no lightning, no dramatic warning music, just an invisible atmospheric speed bump waiting ahead. During a sudden jolt, it can feel as though the plane has dropped hundreds of feet. Your body has a very scientific measurement system for this. It is called panic, but the sensation is not a reliable measurement of distance. Your inner ear detects changes in movement and acceleration. Your body feels the seat move beneath you. Your eyes, meanwhile, are looking at a cabin that gives you almost no useful reference to the outside world. You feel a sudden downward motion, but you cannot clearly see how far the aircraft moved. So the brain fills in the missing information. And the brain is not known for staying calm at 35,000 feet. A quick change in vertical movement can create a powerful falling sensation even when the aircraft loses very little altitude. It is similar to driving quickly over a small hill. The car does not fall into an abyss, but for a moment, your stomach strongly disagrees. In moderate turbulence, the aircraft can experience changes in altitude and attitude while remaining under positive control. In other words, pilots are still flying the airplane. The airplane has not resigned from aviation. There is no single type of turbulence. Some turbulence forms around storms. Inside and near a thunderstorm, air can rise and sink rapidly. That is one reason pilots give large storm cells plenty of space. Other turbulence forms when wind crosses mountains. The air is pushed upward by the terrain, then continues moving in waves on the other side. These mountain waves can extend far beyond the mountain itself. It is like throwing a stone into water, except the stone is an entire mountain range. Turbulence can also occur where winds moving at different speeds or in different directions meet. This is known as wind shear. Near jet streams, the difference between fast-moving and slower air can create invisible disturbances. This can produce clear air turbulence. That is the annoying kind that may arrive, while the sky looks perfectly peaceful. The seatbelt sign is off. The drink cart is approaching. Your laptop is open. The atmosphere sees this and decides the timing is perfect. Pilots and airline dispatchers do try to avoid significant turbulence. They use weather forecasts, radar information, reports from other pilots, and updated turbulence data. If another aircraft reports rough conditions at a certain altitude, following aircraft may climb, descend, slow down, or change course. It is basically a very professional version of, do not use this road. There is a terrible pothole near Denver. But turbulence is difficult to predict perfectly. Weather radar is very useful for detecting precipitation and dangerous storm activity. Clear air turbulence is harder because there may be no rain or cloud structure for radar to show. Sometimes the first clear indication is another aircraft reporting it, and the atmosphere changes continuously. A route that was smooth 20 minutes ago may become uncomfortable by the time the next plane arrives. Pilots can reduce exposure. They cannot negotiate a permanent peace treaty with the sky. For nervous passengers, looking at the wings during turbulence is rarely relaxing. They move, sometimes a lot. This can look alarming because many people imagine a safe wing should remain completely rigid, but a wing that could not flex would have to absorb changing loads in a much harsher way. Aircraft wings are designed to bend under aerodynamic forces. Flexibility allows them to respond to gusts and changing loads instead of behaving like enormous brittle rulers. The movement you see does not mean the wing is loose. It means the structure is doing what it was designed to do. Aircraft manufacturers test wings higher loads beyond what they are expected to experience during normal operation. So when the wingtip moves up and down, it is not waving goodbye. It is distributing stress. The cabin may shake. The overhead panels may rattle. The plastic tray table may perform a percussion solo. Noise and movement make the event feel dangerous. But discomfort and structural danger are not the same thing. When pilots expect or encounter turbulence, one common response is to adjust the aircraft's speed. Aircraft have recommended speeds for turbulent conditions. The goal is not to race through the rough air and escape as quickly as possible. That would be like driving faster because the road has more potholes. The aircraft may also climb or descend to find smoother air, but another altitude is not automatically better. The turbulence may extend across several levels. Air traffic, fuel efficiency, weather, and safe separation from other aircraft also affect the available choices. From the cabin, it may feel like nothing is being done, but the pilots are monitoring the aircraft, communicating with air traffic control, checking reports, and deciding whether a route or altitude change will help. They are usually not wrestling dramatically with the controls. This is not a disaster movie. And if the flight attendants suddenly stop serving drinks and sit down, that does not mean they know a terrible secret. It means hot coffee and standing humans do not combine well with unexpected vertical movement. Turbulence is normal, but that does not mean it should be ignored. The main risk to passengers is often not the airplane breaking apart. It is an unrestrained person or object moving through the cabin. Unexpected severe movement can lift someone from a seat and throw them against the ceiling, an armrest, another passenger, or service car. Flight attendants are particularly exposed because their work requires them to stand and move through the cabin. That is why the simplest protection is also the most boring. Keep your seatbelt loosely fastened whenever you are seated. Not only when the sign is on, not only when the pilot sounds concerned, not only when your drink begins floating. A seatbelt does not make the turbulence disappear. It simply makes sure you and the airplane continue moving together. This is a useful arrangement. The seatbelt should sit low and snug across the hips. You do not need to tighten it until your legs lose diplomatic contact with the rest of your body. Just keep it secure enough to prevent an unexpected trip to the ceiling. Understanding turbulence does not automatically remove the fear. You can know that the airplane is designed for it. You can know that the pilots are trained. You can know that the wings are supposed to flex. Then the plane hits one strong bump, and every fact immediately leaves the building. That happens because fear responds to uncertainty and loss of control. In a car, you can see the road. You can watch the driver. You understand why the vehicle turns or slows down. Inside an airplane, you cannot see the air moving around you. You do not know when the next bump will come, and you have absolutely no access to the steering wheel, which is probably good for everyone involved. The falling sensation also triggers a physical response before the rational part of your brain has time to explain anything. So fear during turbulence is not proof that you are irrational. It is your nervous system reacting to sudden movement in an unfamiliar environment. But you can give your brain better information. The bumps are moving air. The wings are designed to flex. The sounds are usual parts of the cabin responding to movement. And the calm crew is a better reference than your stomach. You cannot control the atmosphere, but a few choices may make the experience easier. Keep your seatbelt fastened. Place loose objects securely. If possible, choose a seat near the wings. The aircraft rotates around an area near its center, so movement can sometimes feel less pronounced there than at the far rear. Think of a seesaw. The middle moves less than the ends. Watch the cabin crew. If they are calmly continuing their work, the situation is probably uncomfortable rather than unusual. Slow breathing may also help reduce the body's stress response. and avoid studying every vibration like an investigator solving an aviation mystery. Airplanes produce sounds. Panels move slightly, engines change tone, a landing gear may create loud noises. A single unfamiliar sound does not mean the plane has begun disassembling itself. Turbulence feels frightening because your body detects sudden movement, your eyes cannot explain it, and your brain assumes the worst. But the plane is not flying through empty space. It is moving through a restless atmosphere filled with currents, waves, rising air, sinking air, mountains, storms, and fast-moving winds. Most turbulence is an uncomfortable part of flying, not a sign that the aircraft is about to fall from the sky. The aircraft is built to handle changing loads. The pilots have procedures for rough air, and the wings moving outside your window are not failing. They are working. The most important thing you can do is simple. Stay seated when instructed. Keep your seatbelt fastened whenever possible. And remember that your stomach is a terrible aviation engineer. It may insist that the plane just dropped into another time zone. But most of the time, you have simply encountered an invisible bump in a very large ocean of air.